So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as study of physical properties of olivine and augite. So if you remember, in the previous lectures we have discussed about the other minerals, like we have discussed about flint and we have discussed about jasper. So these are the these are the basic rock forming minerals. Basically we can say as rock as well as these are the minerals, because the rocks are formed by the minerals. Each rock, the rocks contain either two minerals or three minerals. So here in this topic we are going to discuss these two minerals, what we call it as olivine and augite. So these are the two types of minerals which are found in the different types of rocks. So let us discuss this topic today. So we'll start with the olivine. So olivine is a kind of, it's a silicate minerals. Basically it comes under the group of silicate minerals, and typically it is found in the mafic. Mafic, what we mean mafic here is, it's a igneous rock that has a high iron and magnesium. So mafic is a kind of rock which contains magnesium as well as it contains iron in that. That's why we call it as mafic. So this olivine is a kind of a mineral. It's a comes under the silicate group, that is typically which is found in the igneous rocks like mafic rocks. So mafic rock means the rocks which contains a lot of iron and lot of magnesium present in that, and ultramafic rocks. So ultramafic means more magnesium and more iron content rocks. Like for example, we have basalt and peridotite and basalt. These are the two types of ultramafic rocks where we find this olivine mineral, which comes under the silicate group of minerals. Now, if you talk about the physical properties of these kind of minerals, so physical properties, as we know, physical property means we talk about its color, its hardness, and its appearance, its texture, and uh, specific gravities, and the cleavage or the fractures. That all we discuss in the physical properties of a mineral. So if you talk about the physical property, if you see what type of color it comes in, so typically it is in green and yellow green. So these are the two colors where we find this olivine. So which color we find is green or yellow green. So green or yellow green is the color where we find this olivine in the mafic kind of rocks. What is mafic kind of rocks? That is the magnesium and iron content igneous rocks. So may appear brown black with increasing iron content, and if it has a ultramafic or it has a more iron content in that, so it may appear in the brown or black with the increasing iron content. If you talk about the crystal system, it has a orthorhombic kind of crystal system, and hardness has a Mohs scale. So on a Mohs scale the hardness will be 5 to 7. So 5 to 7 is the much harder compared to the other kind of minerals. So in a Mohs scale, basically 1 to 10. 1 to 10 means till 1 to 4 we consider as a soft kind of minerals. Okay, soft kind of minerals. Whereas 5, 6, 7, 8, 9, 10, till that we consider this hard minerals. Okay, so hard minerals means these olivine is a mineral which comes under the soft kind of mineral, hard kind of mineral, which is 5 to 7. Now what is the specific gravity? If we see, specific gravity is 3.2 4.5, which increases with the more iron content, and cleavage with the poor cleavage in two directions. So if you remember, in the previous lectures we have discussed about the cleavage also. What is a cleavage means? The mineral tend to break. So when you try to break a mineral, so it will break into either pieces, either it will break as a flat surfaces, either it will break as a fractures. So these all minerals, depending on the breakage, the type of the breaking of the tendencies to breaking of these kind of minerals will tell the cleavage of the mineral. So here it has a very poor cleavage. That means this mineral, when you try to break it, it is not breaking with a flat surfaces. It breaks with a rough surface, not with a smooth surface. This is how the olivine looks like. So it comes under the sediments, igneous rocks, which contains a very mafic kind of content. So this is the actual mineral. Here you can see in this you have this is the rock. So under this rock, this is the mineral present, right? So this is the mineral present, which we call it as olivine. So it comes basically in the green or greenish yellow. Now, if you talk about olivine, several important applications. So what are the basic applications? If you try to find out the applications of this olivine, so olivine is a mineral which across the industries in the geology and the environmental sciences. If we talk about the industrial applications, so as a refractory material. So here the industry, as in the industrial applications, it uses as a refractory materials. Due to its high melting point resistant to the thermal shock, olivine is used in furnace linings, kilns and foundries. So these are the huge industrial applications of the olivine. Basically it has a high melting point, that's why it has a resistance to the thermal shock, and olivine is used in the furnaces as a lining. An abrasive material, it has a hardness of 6.5 to 7 on the Mohs scale, and makes it useful for sandblasting. It is useful for the sandblasting, polishing as an alternative to the silica in the industrial applications. Casting sand, olivine sand is used in the metal casting because of low thermal expansion and does not produce the harmful silica dust. Now, if you talk about the geological and petrological applications, so as it is a mineral which is having the mafic kind of, it founds in the mafic kind of rocks. Now, if you talk about the geological applications or petrological applications, in petrological means we are going to talk about the rocks here. So, mental composition indicator, it is a mental composition indicator. Olivine is a primary mineral. It's a primary mineral in the earth upper mantle and helps the geologist to understand the mantle process. So core, mantle, crust. As we know, the earth is divided into core, mantle and crust. So mantle here is basically helps to geologists to understand the mantle process. Now, rock classification, it is a key mineral in classifying the igneous rocks, especially the ultramafic rock like peridotite or dunite. Now, geological and petrological applications, if we see, so mental composition indicator, it is used as a rock classification and classifying the specially ultramafic rocks. Now, gemstone and jewelry. So as a gemstone and jewelry, if you talk about peridot is the gem quality variety of olivine used in jewelry. It has been prized since the ancient times for the bright green color. So due to its bright green color, basically it is used for as a gemstone, and as a gemstone it is used in a jewelry. And space and planetary science, so meteorites and exoplanets. Olivine has been found in the meteorite study to understand the planetary formation in the extraterrestrial geology. Now, coming to the next mineral, which we call it as augite. Okay, so augite is comes under the pyroxene group. So here, when we have seen olivine comes under the silicate group. Now, this augite comes under the pyroxene group. Now, augite is a member of the pyroxene group, commonly found in the mafic igneous rocks. If you see the similarity here, so olivine also, it is found in the mafic kind of rocks. It is found in the igneous mafic rocks, whereas augite also, it is found in the mafic igneous rocks like basalts and gabbro. There we have seen it is found in the basalt and pedolite. Now here this augite kind of minerals, basically it is found in the basalt and gabbro. Basalt and gabbro, these are the igneous rocks which contains a mafic content. Mafic means magnesium and iron. Now, color, if you see the physical property here, what is the color of this augite is dark green, black or brown. So it comes in the three colors, dark green, black or brown. Now crystal system is monoclinic. So crystal, it is monoclinic system. Hardness at the Moho scale, if you see the hardness here is 5.5 to 6. So hardness of 5.5 to 6. Now cleavage is two distinct cleavages at nearly at 90 degrees, and prismatic cleavage we find. Fracture is uneven to conchoidal. Luster is vitreous to dull. So this is not a mineral which is having a luster, very shiny kind of luster, whereas olivine is having a more luster. It shines compared to the this augite, but it is a non olivine is also non-metallic, whereas this augite is also non-metallic kind of structure. And transparency is translucent to opaque, so it is translucent to opaque. Now streak white to gray and green, white to gray or green color. The streak of this augite will be either white in color, either gray in color, either green in color. Now if you see this examples here, we have different types of augite here. So here you have a black, brown colors and green colors. Now applications, if you talk about the applications, so it has applications in different various fields. So if you talk about the application, augite is a common pyroxene mineral. Pyroxene mineral, it's a group of minerals which forms igneous and metamorphic. It forms the igneous rocks, and metamorphic, it is found in a, like these minerals will form the group of minerals like igneous and metamorphic rocks, and has a several applications. It has a several applications in geology, industry, and the scientific research. It has several applications in industry, scientific research due to its physical and chemical properties. Now if you talk about the rock classification, so how does this rock classification is classified? So augite is essential in mineral. It is essential mineral. It's basically augite is an essential mineral, and it is classifying as a mafic and intermediate igneous rock. So it is classified as a mafic rock and intermediate igneous rock, such as it is found in basalt rock, it is found in gabbro, it is found in diorite, and it is found in andesite. So these are the different rocks where we find this kind of mineral, augite. So it helps in identify high temperature magmatic conditions. So if you talk about as metamorphic indicator, so it is found in high grade metamorphic rocks like pyroxene hornfels. So in pyroxene hornfels you will find this kind of high grade in the metamorphic rock, and helps the geologist to interpret the past geological conditions. And industrial and construction applications, so crust stones and aggregate, augite bearing rocks like basalts, gabbro, are used in the road construction. So these augite is a mineral which contains the rocks which contains the augite in present in that. For example, basalt and gabbro. So basalt and gabbro, it contains the augite mineral in that. So these kind of rocks are used as a material in the road construction, and in the concrete, and even in the railway ballast. Railway ballast is the crushed stones, the aggregates, the crushed stones, the which are laid beneath the railways. So for the compression and for the pressure or something like protecting the layer of that railway, that they put the lay this kind of crushed stones in that. Now if you talk about the dimension stones, some augite rich rocks are used as a decorative stone. So the rocks which contains augite like basalt and gabbro, so these kind of rocks are used as a decorative stone in the buildings. So you can just decorate the as a monuments or some kind of decoration we can do with this augite which contains the rocks which contains the augite present in that, and even in the monuments. So scientific and research applications, if you talk about the scientific and the research applications, so it has a petrological studies application. Petrological application means used in thin section microscopy. It is used in the thin section microscopy to analyze magmatic processes and mineral crystallization. So it is used in the thin section microscopy, and it can analyze the magmatic process and mineral crystallization, even in the planetary geology. So as a planetary geology, augite is found as a lunar and Martian rocks, helping the scientists understand the extraterrestrial geology. Now as a ceramic and the abrasive application, if you talk about the ceramic and abrasive application, So it has a application in the ceramic industry. Augite contributes to ceramic glazes and due to its high melting point and durability, and it works as a abrasives. So augite help us. I mean, it can be used as an abrasive material because it has a hardness of 5.5 to 6. Because of its hardness of 5.5 to 6 on the Mohs scale, it makes it useful as a abrasive material. So augite is a pyroxene group of mineral, and whereas we have seen this olivine is comes under the silicate group of minerals. So these two minerals are has a common kind of rocks. It contains some mafic kind of igneous rocks. It is present in the mafic kind of igneous rocks, where it both has a hardness of 5 to 7, 5.5 to 6 or 5 to 7, which is harder on the Mohs scale, and it can be used as a abrasive material. So here are some references we can just go through to find out the more information about this augite and the olivine. We can go through this Keshavlu Chenna textbook of Engineering Geology, Macmillan, India, and Venkat Reddy Engineering Geology. These are all the books or reference books you can just go through to find out the more content about this augite or olivine. So like this, in the coming topics we'll be discussing more about different kinds of minerals, the rock forming minerals, which helps uh, which is used, has a huge applications in the industries as well as in the construction part. So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.